Hi everyone, in this video we are going to discuss atomic mass, but in order to do that we need to go back to the 1800s and talk about one scientist named Avogadro. Now Avogadro was a unique little fellow and he was very interested in determining the number of carbon atoms that existed in exactly 12.0 grams of carbon. And so what he did is he measured out 12 grams of carbon by using just a bunch of different methods. So he would smash it up into a bunch of little pieces, he would do chunks of it, he would do one big block of carbon, and no matter how he measured 12.0 grams of carbon, every single time he found that he had 6.02 times 10 to the 23rd atoms of carbon. And so what happened were that all these other scientists were like, dude, that's so cool, that's so neat. And they decided, kind of in honor of him, but also in just a way of being colloquial, they decided that this number right here was going to be referred to as Avogadro's number. Now, the reason they did this is because they wanted to use it as a point of reference. And it simply has to do with the fact is they wanted to say 12 grams of carbon instead of 6.02 times 10 to the 23rd carbon atoms. Because think about that. In a real life example, if you're in lab, I do not want to yell to my coworker, hey, can you please give me 6.02 times 10 to the 23rd carbon atoms? You'd much rather say, hey, bro, throw me 12 grams of carbon. Like, it's just much easier to say. And so what they did is they came up with this term called atomic mass. And so atomic mass is simply the mass of 6.02 times 10 to the 23rd atoms of each element. So it's unique to each element. So for example, if I wanted to determine how many oxygen, or what the mass was of 6.02 times 10 to the 23rd oxygen atoms, all I would have to do is go to the periodic table and read the atomic mass off of the periodic table. So it says 16.00 grams. We could also do this for nitrogen. If we wanted to know the atomic mass of 6.02 times 10 to the 23rd nitrogen atoms, we would simply look at the periodic table and it would say 14.01 grams. So now I'm going to ask you to try this. How many helium atoms are in 4.00 grams of helium? Good luck. All right, did you get an answer? Hopefully you did. All you had to do was go to the periodic table and find helium. Once you found helium, you needed to look at the number or the atomic mass in the little box for helium and determine what it was. Luckily, the atomic mass is 4.00 grams. So we know immediately that in 4.00 grams of helium, we have 6.02 times 10 to the 23rd helium atoms. It's very straightforward when these numbers match. But what happens when they don't match? How many sulfur atoms are in 16 grams of sulfur? Go. All right, did you get an answer? Hopefully you did. So all you had to do was go to the periodic table and find sulfur. Then you look at the atomic mass. The atomic mass is actually 32.0 grams for sulfur. So what we had to do is set up a little ratio. So we know that for 6.02 times 10 to the 23rd atoms of sulfur, that has an atomic mass of 32 grams. But we want to know how many sulfur atoms are in 16 grams. So you just put in a relative fraction and you just solve for x. So all you're doing is taking 6.02 times 10 to the 23rd, dividing by 32, and then multiplying that by 16, and you can solve for x. If you do that properly, you should get 3.01 times 10 to the 23rd atoms of sulfur. If that doesn't make sense, stop, talk to your teacher, talk to me, or talk to a TA and get some help on this. Good luck, guys. Take care of yourself. Drink water.